Welcome to Study Loop.
This problem references exercise 68, which includes 5 statements that we need to decide if they're true or false. And we're going to be looking at those statements under the assumption that we are looking at multisets. So I'm going to write that here just so we don't forget. That is our underlying assumption here. Now, just as a reminder, a multiset is a set in which an element can be a member multiple times. Okay, so as we go through that, we do need to remember that these are multisets we're working with. So let's look at the first statement. The first statement says the set of A and A, the union of that set with AAA, does that equal the set with A in it 5 times? Is that true? Well, when we're talking about multisets, to find the union, we're going to look at what we have in each of the sets, and the most of an element in any one set is what will be in our union. So in this case, our first set has 2 A's, our second set has 3. The most is 3, so the union would only have 3 A's in it. So this statement is false. Okay, statement number 2. Same setup. Okay, so that left-hand side is exactly the same. And now the question is that equal to the set with just A? Well, we just said that when we take the union of 2 multisets, we're looking at how many are in the most that we have in any one set, and that is what is in our union. So we should have 3 A's in our union. So it's the same. The correct answer is the same in both of these, and both answers as given are false because neither one matches this set with 3 A's in it. Okay, third statement. I have a set with 2 A's, and now I'm looking at the intersection between that set and a set with 3 A's. And the question is that equal to a set with 2 A's? Well, when we're trying to find an intersection, the union we compared and we took the most in any one set. For the intersection, we're going to compare how many are in each set and take the smallest. We have one set with 2 A's, one set with 3. The smallest is going to be a set with 2 A's. That is exactly what we have here. So this one is true. Okay, fourth statement. Again, I'm going to have a set with 2 A's, intersection with a set of 3 A's. So this setup is just like what we had. And we want to know, does that equal a set with just an A? Well, since the last one was true, and it's the same piece on the left, this has to be false. We know the answer is a set with 2 A's. This only has 1. It is false. Okay, last one. I have a set with 3 A's, and I want to find the difference between that and a set with 2 A's. Does that equal a set with 1 A? Well, when we're finding the difference, we're looking at what is in the first set, but not the second. So we're going to do a subtraction. I have 3 in the first, 2 in the second. That difference is 1. So I have 1 A is the difference. That is what we're given here. So this last statement is true. So out of the 5, I have 3 false and 2 true statements.